Hello, sixth grade, and welcome to lesson 3-2. In this lesson, we're going to talk about how to find the greatest common factor and the least common multiple. So we're going to talk about what those things are together, and then we will go through our notes and our guided practice together. So let's take a moment to watch our short lesson video with the examples, and then we'll jump into our notes.
How can you use prime and composite numbers to write the prime factorization of a number? Think about this question during the lesson. Whole numbers greater than 1 are either prime or composite numbers. A composite number can be written as a product of its prime factors, called its prime factorization. How can you find the prime factorization of 48?
Let's take a look.
12 is a composite number because it has more than 2 factors. 5 is a prime number because the only factors of 5 are 1 and 5. Are all odd numbers prime numbers? Explain. No. For example, 9 is an odd number, but it has more than 2 factors, 3 times 3 and 9 times 1. So it is not prime. One way to find the prime factorization of 48 is to write its factors. It is sometimes helpful to start with the least prime factor. What number is always the least prime factor of any even number?
Select your answer.
Two is the least prime factor of any even number. The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. Another way to show the prime factorization of a composite number is with a factor tree. You can use a factor tree to find the prime factorization of 48. Write 48 as the product of 2 factors. Continue the process until all of the factors are prime factors.
All right, so let's give this a try. It says there are many ways to make a factor tree. Select a way to start a factor tree for 48. So for 48, we can start with 3 times 16. Now, if you do 3 times 16, 3 is already a prime number, so nothing is going to branch off of this 3. But 16 is not a prime number. So 16, we can split it into 2 and 8, because since 16 is an even number, you can always divide it by 2. And then when we get to 8, same thing. 8 is an even number, so we can divide it by 2. 2 times 4 will give us 8. 4 is also an even number. 4 can be divided by 2, so 2 times 2 is 4. So to find the prime factorization for 48, you're going to take all of these prime numbers that you have, and you're going to multiply them by each other. So 3 times 2 times 2 times 2 times 2 will give you 48. Or 3 times 2 to the 1, 2, 3, 4th power, right? Because we're multiplying 2 by itself 4 times. Now you can also start, if you wanted to start with 4 and 12. You can split 4 into 2 times 2, and 12 would be 2 times 6. And the 6 could be split into 2 times 3. So you end up with the same prime factorization, no matter which way you go about this.
Start with 6 times 8.
Now here, if we started with 6 times 8, again, you're going to end up with 2 to the power of 4 times 3 when you break it down all the way, because 6 will break down into 2 times 3, 8 will be 2 times 4, and the 4 will be 2 times 2. So you're going to be able to do this multiple ways.
The prime factorization of 48 is 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. How can you check that the prime factorization is correct? You can multiply all of the prime factors and confirm that the product is 48. Now you know how to use prime and composite numbers to write the prime factorization of a number.
All right, that takes us all the way through the notes. We can go back and recap briefly some of the things that we learned in our notes. So 3-2, find the greatest common factor and least common multiple. So how can you write the prime factorization and find the greatest common factor and the least common multiple of two numbers? So there's a lot of information here. Now the video only went over prime factorization, so we're going to do a lot more discussion here in the notes. Now, when we have whole numbers that are greater than 1, they're either prime numbers or they are composite numbers. So let's go back and refresh our memories on what that means. A prime number only has 2 factors. That means you can only make that number by multiplying the number itself times 1. There's no other way to make it. For example, 5 is a prime number. The only way we can make 5 is 5 times 1. 3 is a prime number. The only way we can make 3 is 3 times 1. 7 is another one. Now, I know there's a pattern here where you're seeing that these are all odd numbers so far, but not all odd numbers are prime. 9 is an odd number, but we can make 9 by doing 3 times 3. 15 is an odd number, but we can make 15 by 3 times 5 or 1 times 15. So a prime number can only be made by multiplying the number itself times 1. There's no other option. Now, when we're talking about prime factorization, that's what we saw in the video. That means you're breaking down each one of the numbers until you get down to prime numbers. Now, remember, our smallest prime number is 2. Even though it's an even number, because it's so small, the only way to make it is 2 times 1. Now, on the other side, composite numbers have more than 2 factors. So just like we said, 9 or 15, or here in our example, we have 12. There's multiple ways to make it with a lot of different numbers. You're not stuck with just 1 times the number itself. So we can make 12 by saying 1 times 12. We can do 2 times 6. We can do 3 times 4. Here you can see we have multiple options to pick from. So that's what makes it a composite number. Okay, so now that we've recapped prime and composite numbers, when we find, again, the prime factorization of a composite number, you're going to write it as a product of all of the prime factors that you were able to find. So how do we do that? So you can either break it down one step at a time with multiplication. So for example, if we're working with the number 56, so I can divide it by 2. So I want to try and divide by 2 as much as I can because 2 is my smallest prime number. Now 56 can be made by doing 2 times 28. Now 28 is also an even number, so I can split that and divide that by 2 as 2 times 14. So now I have 2 times 2 times 14. 14 is still an even number. I can make 14 by 2 times 7. So now I have 2 times 2 times 2 times 7. And that is as far as I can go because 7 is a prime number. Now, all of these factors here, the 2's and the 7 are all prime numbers. So I'm done factoring. My prime factorization is right here. I have 3 of the number 2's and a 7. So 2 to the 3rd power, or 2 cubed is what you would say. So that's 2 3 times. So right, 2 times 2 times 2. That's 2 to the power 3 times 7. That is your prime factorization for 56. Now, you could also do this making a factor tree, which is what we saw in the video as well. So if I have 56, I'm going to split it into the 2 times 28. I can split the 28 into 2 times 14, and I can split the 14 into 2 times 7. So here I'm back with the same numbers, 2 times 2 times 2 times 7. So there's only one prime factorization for any number. No matter which strategy you choose to use, you're going to end up with the exact same answer. So if you're more comfortable doing it as factors of a product, if you're more comfortable doing it as a factor tree, whichever way you do it, you're going to get back to the same answer. All right, so next we're going to talk about finding the greatest common factor. So what does that mean? This is the biggest number that is a factor of the numbers that you are using. So if you have two numbers, you need to find the greatest common factor. That means the biggest number that you can use to make each one of those numbers that are your options. So if I'm working with the numbers 12 and 42, I want to factor these out. I want to find the biggest possible number that is a factor of both of my numbers. Now, so first you can do it this way. You can write out the prime factorization for each of your numbers, find the factors that they have in common, and then multiply those factors by each other. So 42 and 12, both of them have 2, both of them have 3. So I could do the 2 times the 3. That's the greatest common factor, is going to give me 6. Another way that you can do it, which is a bit easier for me because it makes it a lot more visual, is I start listing the factors for each one of those numbers. So each one of these numbers is a factor of 42. 1 times 42, 2 times 21, 3 times 14, 6 times 7. So I list them in numerical order. For 12, you have 1 times 12, you have 2 times 6, or you have 3 times 4. And then I look down my number list. I look at these factors and I find the biggest number that's the same in both lists. So here, yes, they both have 1s, they both have 2s, they both have 3s, and they both have 6s. There's no other numbers that they have in common so far. So even if I look down to the rest of the factors, I see that I'm correct. There's no other ones that are, there's no bigger factor that can be found in both of them. So since 6 is the biggest number, the biggest factor for each one of these, that is my greatest common factor. Greatest means biggest, common means the same between both of them, and factor is a part that you can break it down into. All right, so we went over prime and composite. We went over prime factorization, and now we've gone over greatest common factor. So it's the biggest number that they have in common that you can use to make them. Now, our next part is called the least common multiple. Now, the least common multiple, of course, not including 0, is of two numbers, is the number that they share. So when you're looking at multiples, right, you're thinking about multiplication tables. So here, if I want to find the least common multiple of the number 6 and the number 9, I'm going to list all the multiples of 6. And then for the 9, I would have 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and so on. Now, the least common multiple, least means the smallest number that they have in common when you are multiplying those numbers. So if you look at the multiplication chart for 6 and the multiplication for 9, those families, you find the smallest number that's the same in both. That's your least common multiple. Remember, multiple is what you get when you multiply. Okay. So here I can see with 6 and 9, the smallest number that they have in common is 18. Yes, they do have 36 in common. They may have additional numbers in common as you get bigger and bigger. But the least number, the smallest number that they have in common is 18. 18 is a number that can be found in both multiplication tables for your 6s and for your 9s. All right, let's take a look at your guided practice. Number 1 says, how can you write the prime factorization, find the greatest common factor and the least common multiple of a number? So we know the prime factorization is the product of the number's prime factors. So once you break it down into all of its parts, that is the product. The prime factorization is what you get, those numbers you get that you would multiply by each other that are so small they're down to being prime numbers. The greatest common multiple is the biggest or greatest factor that they, the greatest common factor is the biggest or greatest factor that they have in common, and the least common multiple is the first or the smallest multiple that's shared by both of those numbers in both of their multiplication families. Number two, what are two different ways to use prime factorization? You can either create a product of the number's prime factors, or you can create a factor tree like we saw in the video and up above in our notes. Number three, why is the greatest common factor of two prime numbers always 1? Well, because prime numbers only have two factors, right? Just 1 and itself. The only number they're going to share is that 1. Number 4 says Grant finds applesauce in packs of 8, but now finds juice in packs of 3. Will his least common multiple change? Well, no, because the least common multiple is still going to be 24, because 8 and 16, neither one of those are multiples of 3, so it's still going to stay at 24, because 8 and then 16 and then 24 when we're looking at the different multiples of 8. For number 5, Sarah says you can find the least common multiple of any two whole numbers by multiplying them together. Provide a counterexample to show that she's incorrect. So if we have 6 and 4. Now, she says if you multiply them by each other, that answer is your least common multiple. So 6 times 4 is 24. But if we list the multiples of 6 and we list the multiples of 4, their least common multiple is 12, right? Because 6 times 2 is 12 and 3 times 4 is 12. We don't need to go all the way out to 24 before we find numbers that are in common. For numbers 6 to 8, we were finding the prime factorization. So for 33, it's just 3 times 11. Both of those are prime numbers, so we cannot factor them any farther than that. For 32, you can break it down into 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. 19 is just going to be 1 and 19 because that one is also a prime number. For numbers 9 to 11, we found the greatest common factor. So for 18 and 36, when we factor 18, 18 can be made by 1 times 18 or 2 times 9. So 36 is 1 times 36 or 2 times 18 or 3 times 9. Or sorry, 4 times 9 is 36. So the greatest common factor, the biggest number that's in between these two, is going to be the 18, because we can make 18 by 1 times 18, and we can make 36 by doing 2 times 18. All right, for number 10, we have 22 and 55. When we list out the factors for those, the biggest number that they have in common is the 11. For number 11, when we're listing out the factors of 100 and of 48, the biggest factor that they have in common is actually 4. Now for numbers 12 to 14, we were asked to find the least common multiple. So we listed all the multiples of 2 and all the multiples of 5, and the first number that they have in common, the smallest one or the least common factor or common multiple that they have, is the 10. For number 13, for 8 and 12, the least common multiple they have is 24. And for number 14, between 8 and 10, the least common multiple is 40. So if you have any questions, please go back, review your notes, review the video, or you can ask in class if anything comes up. All right, that's it for today's lesson. If you have any questions, let me know. Take care. Bye-bye.